Alright, so in the last video we showed how to do the input wiring of a K6K Kinetix 6000 servo drive, right? So this is the inputs, and this is exactly how this will work. I'm going to show you how to do the ARM instruction so that you can actually track those inputs properly in this video. Now, again, so just a little note, if you have trouble with video quality, always click the gear icon below. Make sure you upgrade. You click that and it will enable you to pick a different resolution that we currently have, and that's based upon your internet connection. I do record at 1080p and I record in 4K, so you should see crystal clear quality when you change that, just as if you were doing it yourself. So without further ado, I have a trend right here set up, and we'll come in here and show you this. So the registration, I kind of went ahead and pre-programmed just to kind of show you the way the registration works. Okay, so the input status, what we're doing here, so to start this off, in the event of using a MAR instruction, you're going to scroll over to the very side. You're going to come over to your top bar up here, and you're going to get your it's a motion event. That's where you're going to have your motion event, right? So you're going to have your motion arm registration, and then you're going to have the corresponding with that is going to be your motion disarm registration. So you want to disarm it when you're not running, or when you just first start up. So in my case, I'm saying, okay, if the motion axis is started on my servo, then I'm going to do it one time. I'm going to disable it the first time, so I want to ignore that. So just to kind of show you a brief indication, I have this hooked to a push button just to show you really so I can have a controlled environment. But in your case, you're going to have a photo eye, you're going to have a prox, or you're going to have some kind of high-speed indicated device that is hooked to an input, or hooked to your K6K registration input 1 or registration input 2 to have this working. Now, in this case, let me show you this real quick. Now, quickly go over the ARM instruction. You're going to pick your servo. This is going to be the only servo. The only servos allowed to be used in the ARM instruction are position servos. So in my servo system over here, you can see I have axis 1, 2, 3, 4, and then I have the trainer servo and the virtual master. So the virtual servos are axis 1, 2, 3, and 4, and the virtual axis, the virtual master axis. The only real servo that I have in this actual trainer module is the actual trainer servo. I've named that accordingly. You can see that. So note that registration should be done on, and only done on, the actual position servos. So meaning a servo, it could be any kind of position servo for that matter, as long as it's a real device. Okay. Now the second indication here is just the second thing is just a tag for that, right? So this is just a tag you make for your actual MAR. Now the third indicator is the trigger. You can select the position, or the positive edge, or the negative edge. Okay, so we're actually doing a positive edge, and we're showing that. Now in this instance, we're actually not using the window registration. Now we're opting not to use the window registration because we're not using the window of what we're doing in our servo. Therefore, the minimum position and the maximum position is something we don't even care about. So if this was enabled, you would care about the minimum and maximum. Okay, so keep that in mind. Now, back to this last section of this little portion of this instruction. This is where you're going to set what actual 24 the 24 DC device or 24 DC input that you're using. Where we talked about the registration input 1, registration input 2, you have 2 registration inputs on a Kinetix 6000 servo controller, right? So in this instance, we only have one connected in our trainer environment. We only have one connected, right? So we're going to use one. Okay, so you could use both if you have that wired up. Now, all of these controls, there's a very, very diverse atmosphere as far as servo controls. So I want you to understand the proper protocol and the proper way things work. So you're probably wondering, well, Shane, how does this work? How does this work? I mean, is it even worth doing, right? So let me show you this, right? All right, so come over here, and we're going to disable this temporarily, and I'm going to show you something. Okay, so in the instance of what we're doing right here, we will not be able to fire this ARM instruction anymore. So you see there's a PC complete bit. Now to describe those, this is an instruction. So the instruction has the enable, the done bit, the ER, which is the error bit. The IP is the in progress, meaning that it is active and waiting on the event to happen. And the PC is the process complete bit. So in the current state, I do have it disabled. So if I push it, sure, I can use the input status or the actual 24 volt input of the actual K6K anywhere I want to in the program. However, I'm not going to benefit from the speed of the servo. Speed of a servo is based upon the course rate update of the actual servo. You know, how many servos you have in your actual, your controller organizer over on the side. So in my instance, I wouldn't benefit to a 2-second update time. So my servos are updating every 2 seconds, right? Now I can get them a little bit lower because my max right now, my max is even below one millisecond. So I have this at 2 milliseconds, right? So I'm updating my servo and the information in my servo every 2 milliseconds. So that's the benefit from it, right? So if you're tracking and you're getting, this gives you a high-speed way to track product and high-speed way to do things. Now, obviously, too, with this being said, when I arm an event, I can actually now come in and add another scenario where I'm actually controlling. Let's just right here, I can add an event-driven system, an event-driven task. And I can have the event trigger off the access registration and have that event trigger. Now I can execute this all the time, or I can execute this when I want to. So if you were to look at this, you would see this right here is the only current thing in there. When I push the button, then it activates, right? It activates. So if you were to see right here on my actual trend, when I push the button, it activates. So if I push the button and I come up here, I still have it held, it activates. Now, if I let it go, it goes off. Now, why does it go off? Because of the simple thing down here, I have it turned off down here. Now, I'm just doing that to show you the illustration of using an event system, if you wanted to use an event system, because there's often the indication of how do I track things? How do I use things? How would I go about doing things? Now, what are the key indicators that you would use an event tracking system for? Right? You would use this for tracking the length of a product, or you would track a product through an actual machine. You can do that as well. Those are two key things that you can do. You can do many, many different things with this, but what I'll tell you, here's the epiphany moment that happened for me. I want to describe this. So the current way that this system is working, that I have right here in front of you, is I'm looking at the registration input, and if the servo input is inactive and the servo registration ARM status is inactive, then I want to turn on my event registration. So I want to have the ability to track an event. Now, every time your servo input comes in, you will not be able to track it unless you have an event armed. Therefore, you need to have an event armed every time. Every single event that you track, you need to have an event armed. So all this is saying is, and this is where I'm getting at to that moment that really tied everything in to get together for me, and this may tie everything together for you, is what the MAR instruction does is when it's in progress, it tells the Kinetix 6000 controller and logically to actually monitor those bits better. It monitors those bits in a different logical path inside of that actual controller. When it does, it tells the controller, the K6K or the Kinetix 6000 monitor the controller. It monitors the different bits and stuff and sends different bits to the PLC processor. So with that being said, every time you trigger it, it allows if you can think about, there's logic inside that we create inside of our PLC programming, and say for instance any kind of drive has a natural standard logic behind that drive. This being another type of drive, this is a Kinetix 6000 servo drive. It's a servo controller. It has a specific set of logic behind it. That's what we're telling it to do. We're using the timestamps behind that and using everything behind that. So this goes back, and that's why I put this note in here. It says the event has to be armed on every single time you're using it, right? And I had a little typo right there, but again, that was the epiphany moment for me that really said, okay, well, that's the way I need to understand the way it should be armed. Okay, so coming in here, this is why I made this quick trend, and I'll show you the tricks I did for this trend real quick. Is I put the event, the registration event status. I put the registration event number 1 armed status in there. So I'm saying, did the status happen? Is it armed? And is the registration event, did it actually work or come on the actual K6A controller? And then I'm looking at the process control, or the process complete bit. So I have those under different colors, and what I did is I came down here and I did an isolated graph. So if I don't do an isolated graph, it looks like this. Very, very hard to read. So there's a very easy indicator right here, is the isolated graph, to get a different point of contact so you can see it. Now, to give you a better indication, I have this wired to a push button instead of a proc switch, or instead of a photo wire or something that would be really, really quick. I have this wired to a push button, and I don't actually have my servo running because of the simple fact of the noise. I want to actually, describe the way it works before, we talk about it, or before we talk about it under, there's the system's running, there's noise and stuff like that. So you don't actually have to have it running to track a system, but you should, right? You definitely should. So I'm showing this right here. I'm pushing the button, and I want to come in here and highlight this. So you see right here where it has the motion event is off, the registration is on, the input status is off, and the PC is off, right? You can see that right here. Now when the event has happened, right, the event is on, the input status is on, and the PC is on. So that's the way that the firing order and the way things are, and the quickness and the sharpness of the way that I have this controlled. Now, you can argue the fact of actually changing this from an armed or the armed status. You can have this merely changed to an IP, and I'll show you this. You can use the instruction IP of this, right? You can use the instruction IP, which is the in progress bit, and it still will work, don't get me wrong. But here's the problem here, is anybody that's ever seen me program, and this is the way I want you to understand the way things are broken down. The scan rate of a servo, again, the course rate update is at 2 seconds. Okay, so I'm getting data from a servo every 2 seconds. Now, if I use the IP, not only am I subject to using I can't really see the indicators down here. I have to now. If I go down here and look at my trend, it's still working. It's still doing what it's supposed to be. But that's why the trend is there, right? But if I look at my registration, if I look over here at this this process bit, some of these are going to be so quick that you can't see them. But here's the benefit to what I'm talking about, is the separation of using the servo attribute, which is the servo itself, which is the servo tags, instead of the actual the instruction tag. The instruction tag is more it's more application based, meaning it's more task based. So at this point in time, it's going to scan every 50 milliseconds, which in most machines is not a big deal, right? But in some very, very, very high speed machines, you need to track the actual armed instruction, because what I'm doing here is I'm saying, okay, instead of monitoring the input status or the IP, the in progress status of the instruction, what I'm doing is I'm saying I'm looking directly at the servo. So what is this? And this may add some clarity to tying this loop in for you as well. The ARM instruction, what it does is it actually tells the servo to do certain things, right? So this ARM instruction is arming this servo, right? It's arming the servo bit, right? So it's telling this servo what to do. This ARM instruction is telling the servo what to monitor. Now again, this is where you would come in and have many more like advanced controls, and you would do different things. In my case, I'm just merely cutting on a bit over here, not a real fancy thing, right? Not a real big showstopper show thing that, but I wanted to give a good indicator of, hey, this is the way a MAR works, and a motion shutdown also too works with it. So with that being said, and this top rung up here, all it does is just have a no operation. So I'm just giving this as a status for everybody to see. So using this, again, every time a input comes in, a 24-volt input comes into the number 1 registration, right? We talked about registration 1, we talked about registration 2. Now, every time a 24 volts comes into a registration, and that transition happens at 21.5 volts. So it goes from 0 to 1 at when it goes over 21.5 volts. So when that transition happens physically with our device, right? In my case, it's a push button. In your case, it could be a photo eye, a prox, or whatever the case may be. Then what it does, and I'm saying if it's a 0 and if the event armed is not on, I want to arm it so that when the button's pressed, I can track it. And then the PC bit, see when I hold it down, the PC bit is live. The PC bit is on. That means it transitioned, because you have to have a process complete every time you have this event happen. Or if you don't, the next event that comes right behind it won't track properly. This is why I put down the error bit down here to actually shut down that event tracking. So again, this is breaking down a high level of a way a ARM works. And again, you can use this for many different things. I've seen this used in product tracking. I've seen this used in product measurement. I've seen this used in many different things. It's a very simple way to do it, very easy way to do it. And you can also, Rockwell has different ways that they like to program. So this is a very simple scenario for a one tracking system. Like say if you want to track one product, say if you had 3 or 4, you would do this a little bit different, right? But I want to actually show you a good solid way to understand how to do this, and then using the trend factor, coming in here and showing the way this thing triggers. So if I'm pushing this off and on, you can kind of see the way that holds in, and it's probably me holding it with a button that's not getting a good indicator. But and let me show you the way this would work on a real high-speed system, because you're going to see a different outcome. So if you were to see that, this is the reason why I do that, right? So if I were to push this really quick, it's really hard to see, right? So that's why I wanted to come in here and give you a solid indicator of the way the push button works, of the way the actual input works, I should say. Now, some of these it's probably because of the way I'm holding the push button, the way it's being triggered. But again, coming back, this is the way the process works and stuff. So you can actually see how easy that transition can be. The main components that you need to understand is the way it works, right? And the way some of the things you need to monitor. And now keep in mind, in programming, there's a million different ways you can do things. If you can think it, you can do it. But I'm giving you a rough example of one indication of how to work and how to arm a ARM instruction or have an event armed in your process, right? In this environment, this is a version 32, and it's running at L73. So I wanted to actually show you that and show you how this was functioning, because again, when it's important to know your devices that you use with the K6K controller are going to determine how you do things. The way you have your process set up are going to control, is going to determine things. The way you're calling, maybe you're using, like I showed over here, maybe you're using an event-driven task. You can have all of this logic in this event-driven task if you wanted to, and just say, okay, the only time I care about it is when I'm pushing the button, or when I'm getting the input in, or when my device is being used. That's the only time I care about it, right? Other than that, I don't really want to. I don't want it in my scan time. I don't want to mess with. I don't want to, anything like that. So this is the reason why I wanted to kind of shed a little bit of light on this. But please note that there's a diverse environment, a lot that goes into this, and I want to give a solid indication of how this system kind of works. So at least it gives you a understanding and a way to kind of methodically think about this. So hopefully this really helped and guided you through understanding how a MAR works, right? Remember, if you want to register an event, you need to make sure that you get a process complete bit. Now that means you need to register, you need to arm that event right before that input comes in, so you can track it properly and so you can use it properly. And then you can build as much logic as you want to around it. But again, if you're having servo problems and stuff like that, if you're having registration problems, an oscilloscope, put an oscilloscope on it to understand the way things are going, and as far as like maybe you're getting a spike in your power. In this indication right here, we're not using an auxiliary power supply. We're using a 24-volt power supply that's derived from the K6K. So with all that being said, hopefully that gave you a lot of information in a short period of time about this ARM instruction and how this thing works. So if you have any questions, please list them below, and we'll carry on, and we'll see you guys on the next one.